Hi everyone, welcome to this video. In this video we're going to convert the original Smiths tachometer from an RVI, so that's a current sensing tachometer, to an RVC. It's a volt sensing tachometer, and we're going to do that by using this Spyida conversion board. So this will remove the original electronics and we'll install this new circuit board inside of the tachometer, and this will mean that I can use the tachometer output from my ECU to actually run this original tachometer. And there are several inputs that you can choose for this board, so it will also work with the original ignition or some electronic ignition system if you wish, but I'm going to use my ECU to send signal to this tachometer. I'm going to try to keep this video quite short because Spyida has some videos on YouTube on how to do the conversion, and there's also a very nice explanation by someone who's converting a Jaguar tachometer. So I'm going to go pretty quickly, hopefully. So we have to remove the bezel, which you can just turn. So I'm going to remove the little seal. You can turn the bezel. Like so. And it should pop right off. So the bezel and the glass. You have to remove the little needle. This is quite tricky. I'm going to use a little bit of paper to protect the face of the instrument. Spyida recommends using a fork to pry it up. Maybe if we take the mechanism out of the housing first, so we'll do that. So there are two screws that are holding the mechanism to the housing. And these two. So here we can see the old board. I finally managed to get the little needle off of the shaft, and the way that I did it is by using two spoons like this onto two screw mounts because they are supported, so, and then pressing outwards. This gave enough leverage to take the needle off. At first I thought I actually broke the mechanism, but it came off cleanly. So I recommend the two spoon tricks in favor of the little fork leverage, because you can get a little bit more power with this. So now I can remove these two little screws to take the face off. Okay. So we have to remember that on the mechanism this flat section is the bottom, because we have to install the dial plate like this. So now it's a lot easier to remove 2 screws to get the old board off. So we're going to keep those screws because we're going to use these to install the new board. I already cut the wires off of the old board, but there's one transistor here that's I think it's grounding the board on the back plate, so I have to cut this one as well. Now I think we can remove the old board. There's an inductive pickup here on the back that we're going to need to remove. We're going to cut the wires and then the old board can come off. So that's the old board that we're not going to use anymore. Now this is the back plate. This is our power in connection. And then there's an inductive pickup where the coil wire will loop through, and this would sense the current. But we're going to remove this because we're not going to use this anymore. It will just have a 1-wire input apart from power and ground. So there's a small nut on the end. I can take the little block off, and then another nut. So this is the bare mechanism that we need to use to install a new board. So I'm going to start off by removing the old power connections, and then we need to install the new board on the mechanism and installing new wires. Now we have removed all the old wires, we can install the new board, which uses these 2 top mounting holes. And on the back of the new board there's a small little screw that goes to the back. So the board sits on here. Okay. This thicker red wire needs to go on this power input connection. Then there's a black wire and a red wire. They need to go on these 2 connections on the front of the mechanism. You have to put them in and then check if it works, and otherwise you have to switch the connections. So I'm going to clean up the wires a little bit, and then we're going to solder them. I soldered up all of the wires, so the 2 powering the coil, and then the positive. It will take ground from the mechanism. The only thing that I need to do is to add this wire, which is the input wire, to the little new board. On this new circuit board you can see 4 pads, and this is for the input for the board, and there are 4 pads because it depends on what kind of ignition you're running or what kind of tach signal you want to use. So you can choose between a couple of different inputs, I'll be using my Megasquirt ECU. So I'll be using pad number 4 as an input. So I'm going to solder a wire on here, like this, and then I'm going to enlarge this hole in the back plate so I can put the wire through there and have it come out in the back, and put a connector on there so I can leave this in. You also need to use pad number 4 here as an input to calibrate the new board, which I will do now, but I might have to repeat again afterwards. Okay. So now I'll feed the wire behind the backing plate through this hole like this, and I'll put a connector on the back. So we're going to test if we have wired it correctly. So we're going to get a power source and put some power on here. If everything is okay, this should be able to turn freely. If not, we'll have to switch around these power connections. To test our wiring, I've connected 12 volts to the power input, and this is a ground. So once I connect this, we should see movement on there. I've installed a new board, and I installed the back plate and the needle. Now we're going to try and see if we can power it up. So I have a 12 volt power supply. If we're going to power the board up, I've connected the positive to the power in stud on the rear, and I'm going to put ground on the chassis. So we're going to probably see the needle move up. Okay. So that's the board powered up. Now we're going to try and see if our input works. So I have my laptop here, and we're going to play some audio files. And there's connection here, so this goes to my laptop. We're going to put the black on the ground and the red on our input. Now we can play this. So it works, however we need to adjust. There's a little screw terminal on the back of the board. When I play the 50 Hz file, it should only go to 1500 RPM. And it was almost at 4, I think. So we'll adjust it. So we'll put 50 Hz on repeat. So this should go at 1500 RPM. So that's right on 1500 RPM. Now we're going to play a 100 Hz file, and this should go to 3000 RPM. So we'll see how close we're there. So that's reading a little bit low. So that's right on 3000. We're going to back to 50, so we're going to see it will read a little bit too high here. But that's, well, still quite okay. We'll go 200 Hertz. So the 200 Hertz file will read at 6000 RPM, and that's the one that I really want to have very accurate. So it actually reads a lot too high on there. So that's right on 3000 or 6000. Reading a little bit too low on 3. And actually quite good on 50. They say you really want to test the tach in the orientation that it's going to be in the car. So hopefully putting it a little bit more upright. 100 Hertz. That's a little bit too low on 3000. Maybe a little bit too low on 6, so we can adjust it upwards a little bit. Well, that's actually very nice. So we can turn the power off. So we'll leave the adjustment as is, and we're going to drill a tiny little hole into the back of the case. I already marked it, so that we can adjust the calibration through the back of the tacho, so we don't have to disassemble everything if we need to recalibrate. I'm going to press on the needle a little bit firmer because it's loosely on there, to make sure that I could get it off if I needed to. But the board works, so it's quite nice. So now I can use the output signal from my ECU to run the tachometer without any conversion boards, and I have new electronics in there which make it very reliable for the future. I drilled out a small hole in the back plate so I can feed through this cable, and I put a little bit of hot glue in there just to take the strain off the cable, and I put a spade connector on there so it's quite easy to connect. Now we can reinstall this back into the housing. And I drilled a small hole here so that I can use a little screwdriver to adjust the calibration from outside the case, so I don't have to disassemble it again. Okay, I reassemble it with the shorter seal, and the only thing that we're hearing is the mechanism. So the glass is nice and strong in there. Our input cable, our ground stud. Then we're going to add the O-ring that goes on around the outside to help it mount to the dash. And you know, I replaced all the bulb holders, so we have the main bulb for the lights, then we have the 2 warning lights that go in here. Voila. So this is our converted tachometer. It's going from an RVI to an RVC tachometer, and I'm using the ECU output in an original Smiths tacho. So the dashboard will look completely original. There aren't any conversion boxes between it, so the output signal from the ECU will drive the tachometer without issue. We've already calibrated it, so I'm quite happy with the results. This video wasn't too detailed, but there are a few videos online, one from Spyida themselves and also another one that shows you step by step how to convert your RVI tachometer with the Spyida conversion board. But I hope you enjoyed this video, and I hope you see you next time. Don't forget to subscribe to the channel so you won't miss any of the upcoming videos. Goodbye.